Okay, so the clock struck 6, so I guess we can start. Hello, everyone. I would like to welcome you all to the 6th edition of the Codest Meetup. It's a special day for us because it's the first time where we are hosting an event fully in English. My name is Monica, and I'll be the host of this event, as you may assume. I would like to thank you all for joining us today. And without further ado, let's just move to another slide. Today, we will take a closer look at JavaScript-related aspects, and Azadin will show us the magic when it comes to event loop. And for those of you who might not know, here at the Codest, besides specializing in Ruby, we also work in JavaScript, and our meetups usually revolve around those two programming languages. About the event, what's important about today's event is that we will have a quick Q&A session. So please hold your questions till the end, and then Azadin will answer them all. And I guess that's all from me. And now I'm just giving away my virtual mic to Azadin.
So, hello guys, my name is Azdi Benika. I'm software engineer here at Codest. So mostly I've been doing like JavaScript for more than 5 years. So in this talk, we're gonna talk about the event loop, okay? And the event loop is a critical component for you guys as JavaScript developer. So we cannot talk about the event loop without introducing the problem, why event loop does exist, okay? And then we're gonna talk about the event loop in the context of browser, and then in Node.js. Then we're going to talk about event loop in React Native briefly. So let's go. The first thing is that we have to determine our problems, you know. So guys, you are a JavaScript developer, like for frontender or backender, okay? You know that JavaScript run in a single thread. And we mean by this is that JavaScript run in single thread. We mean by that we can have only one task that can be executed in one time. What does that mean? It means that if we have complex task, and that task take like 5 minutes or like 2 minutes or like 1 minute, it's gonna block the other task that should be executed. And this is a problem, you know. So this problem can lead also to browser freezing, like for like frontender. You have experience and like you have like a button, you click on the button and there is no interaction. And maybe the effect, there is an effect after that. As well as you can resolve the problem of like, for example, HTTP requests take a while to get processed. Okay, in this situation, we can have like problem of connection internet, problem of another thing. But if we see that in the context, like we have only single thread, and think that we have a handler, and that handler will like read from a file, read file synchronously, and we like that file is heavy, you know. And this will lead to a problem that like our handler will be stuck like busy fetching data, and will block all the requests to get handled. And this is a problem. So you guys like every day, like your work as JavaScript developer is facing code. That's real. And so let's see that, for example, in one of your day, like you face this this script. This script is just like simple. Think about just like we have a button in HTML, and this script is embedded in your HTML. So this script is what it's about. It's going like, for example, we're going to get just a button, and then we're gonna add an event loop. Okay, we're gonna add the event handler. So when the user click the button, it will execute the code inside this callback. What is this task about? Because the callback is just like a task. Okay, so what is this task about? First, we have set timeout, which will run in 0 time. But the second thing is also set timeout, which will run in 0 time. Those like timers will log, like for example, the first one is going to log T1. The second one is we have like promise. Then what's going to happen is going to log P2. and then we're gonna have T2, and then we have set him out for another one, like for T3. Then we're gonna resolve a promise which will log P1, and then we have Q micro task, which is special function. If you don't know, you will see that later, but it's going to log M1. And then we have log just sample log C. So if you can see, this is just like sample scripts. So guys, can you predict the output of this script? If we execute this and the user click on that, can you predict this? Well, I'm not going to let you wait. The order is in this order. If you can see, you can see that we have C, which is at the bottom, and then we go to P1, which is promise, and then to M1, then to T1. Things are not ordered, right? So what's the problem in here? And the problem is that if you cannot determine how things is going to be executed in this order, predicting this, that means you're lacking of understanding a critical component, which is the event loop, okay? So in this talk, guys, I'm going to help you to understand, when you see something script like that, you're going to understand, predict the output of this. And so also in our talk, I'm going to tell you that how could a misuse of the event loop could lead to browser freezing. The same thing I'm going to let you understand how event loop could for example help in achieving concurrency in NodeJS services. But guys, you see, I'm talking two platforms. I'm talking about browser, which is browser freezing does exist only in the browser, and HTTP request, which is backend. So yeah, we are talking about event loop, but in two platforms, but they are different in their behavior. So first of all, we're going to discuss the event loop in browser, which is very important to you guys as front-ender. So, but the first question you can ask, guys, is that what is an event loop? What is an event loop? Well, the event loop, think about it, it's just like a main program that's going to start before everything you run, okay, before everything. It's just like a function, a program that's going to loop, and that program has a relation with a queue that have tasks. And you know that queue in data structure is we have first task in, first task out, so the first in, the first out. And so the program will check in the queue if there is any task. If there is a task, get one, execute this, and repeat. Well, the event loop is complicated than that, but we will see how things is later. But the second question you can ask, guy, where does the event loop exist? Where does it live, right? So to do that, to explain this, we have just schema, simple schema about interesting component in a browser. So we have here, we're going to describe this. The first component is heap. Well, heap is just think about it, just a magic state management, memory management, sorry, management, space, memory space management. That encapsulates everything for you, so you don't need to care about reference, the allocation. Everything is handled for you guys, right? The second important component in browser architecture is call stack. Guys, the call stack is not just related to the heap. It's not just related to browser, okay? Even for example in our platform of Node.js. So what is call stack? Call stack is a function execution context tracker, but I bet you didn't understand this. Why? So let's go have these sample scripts. Call stack is only related to the execution of a program of only one task. We have here just sample scripts. You can run that in Node.js or in browser. It doesn't matter. So we have three functions: Twitter, Google, GitHub. And then later we call GitHub. And so if you can see GitHub call Google and Google call Twitter, and Twitter will log everything. We have Twitter, Google, GitHub. You have to put in your mind that every task, every code in JavaScript should be wrapped in a function. It should be wrapped in a function. Think about this, you see that, okay? For example, in a browser, our entry file, like, it's wrapped in the function, and you can have like the access of window parameters. You have access in like in your file, you can access the window. That's come from function. The same thing if you are running this code in Node.js, you are able to access global dir name, because for example, Node.js will take your file and execute that as a function and pass parameters. So why you have like access to Google global dir name and things like that. But it doesn't matter the platform. It's just like a function argument. Everything is a function. Everything. The global is a function. And the function is a task that's going to be in a queue of event loop. Okay, let's see that later. But for now, you have to put in one thing in your mind, that every function call, create a new frame up in a call stack, which should help like the program to like track the context where we are. For example, if you execute this function, like we have a global function, execute this, will lead to a new frame in the call stack. We have global stack. That means we are in the global. We can access variable, access anything. There's a complicated thing here. But let's see now. So when we have this context, we're going to execute this function. Like we're going to declare Twitter, global, GitHub, and then we come back to call GitHub. Like I said, every function call create a new frame. GitHub will create a new frame on top of GitHub context, because we call this function on like in global context. So since we have GitHub context, we are in GitHub function. We're going to execute that function. So here we have console log. What's going to happen? Console log also is a function. So it's going to create its context, execute its internal, and then we're going to have like a log at the right GitHub. Right? Now what's happened? We have finished the GitHub function. We're going to pop that context and come back like to Google, like to our code in the GitHub function. And now like the second instruction is to call Google, right? What's going to happen here? Also create a Google context. Boom. You see? So now where we are in the global context, Google context, and then if you remember, we got that from GitHub context and from global context, right? So let's see now. We have console log Google. We have created context and log Google. Then we pop that. We have Twitter. Twitter will create, calling Twitter will create a new frame. You see? So here this frame, and now we have to execute the Twitter instructions. For example, we have the console log. We create a log context, log that Twitter, and remove that frame from the code stack. Now where we are in the function, Google context, which means, but there is nothing, no task after Twitter function. You see, we have nothing. So what's going to happen? We have to remove the context from code stack. You see, so now we are also in GitHub context. The same thing is going to happen. And we have another thing about after the GitHub. So also remove that global context. So that's how call stack works, right? So this is about browser architecture. So we talked about heap, we talked about call stack. Let's talk about web API. After a millisecond, now you see that we have executor and event loop queue. Like I said, event queue has a queue that holds task. Okay, that holds stuff. So the executor will pull task, execute that, and track the execution context using call stack. Okay, and try to allocate things in the heap. So how things is going to work. Now what's left to us is talking about web APIs. So web APIs, guys, that there are APIs provided by browser where we can access them using JavaScript. For example, DOM to manipulate our DOM, add event listener, create button, remove button, and network to fetch some data from APIs. And we have timer, for example, to set them out when things sent enter what they are, set them out. Like for example, we schedule a task that should be executed after a period of time. So this is the general. This is where the event loop is located. So if you can see, like for example, we have task in event loop, we get that, execute that, track them in the call stack, allocate in the heap. And if we need any access from browser, we call web APIs. That they are by itself will schedule a task in the event queue. We will see that later in details. So, but like I said earlier, that event loop is not just like, it's complicated. And we mean by that, it doesn't have only one queue. We cannot have only one queue, because if you still so in like on code snippet, you said that we have scheduled different tasks, but they are executed in different order. That means we have different queues with different priority, right? With different priority. So let's see those event phases, and we mean by them, we mean by that like it's queues. So we can define this into two parts. We have micro task and macro task. Macro tasks are like poll timers. Poll are just like the main queue that the event loop start from. We can have like, for example, if we register a handler in button, and that when we click on a button, then that handler will be scheduled in this poll. Okay, right? And timer, if we like, you call set time out and things like that. Micro tasks, like we said, so it's about like, we're gonna see that a little bit. So for example, like poll, like I said, it's just like when there are tasks that scheduled. For example, we have a network callback, or maybe like event handlers that should be scheduled in here. Timers, like set time out, set interval. All those tasks should going to be executed scheduled in that timers. And micro task is a special queue, which event loop check after the current task finish. What do we mean by this? We mean if we are executing this one thing in poll and we finish this, we have to go to micro task, execute all the other tasks. And micro task hold all the tasks that are in micro task are produced by calling promise, either rejecting or resolving, and calling queue micro task, if you remember. So how things work? How does things work here? So like I said, the event loop start from poll. You cannot guarantee that, but basically it's to start from poll, okay? And start executing only one task. In poll, we can only execute one task and move to another queue. For example, we can execute one poll task and move to timer. But like I said, that micro task has a high priority, which means like when we finish a task from poll, we have to go to micro task, execute all the tasks, and come back to like timers and move like around. So we're gonna see some simulation to understand really the event loop, how does it work. So we're going to come back to our scripts. We have just like log A, which is the starting point. So if we're gonna simulate the execution that is using the event loop, okay? So the event loop, we have poll, timers, and micro task. What's going to happen here? The first thing is first, everything is a function. And this block is by itself is a task that's going to be scheduled in the poll, right? So when we execute this, so when we have a task in here, the event loop executor will start from the poll and start executing this. So like you see here, like we're going to get the query, the button element, and then register task, and then just log A. That's what's gonna happen. Since we finished this task, nothing is here. So what's now? Well, it's not that like we're gonna wait for a user to click on the button to schedule that task. That task is going to be executed. Scheduled in that task is going to be executed and scheduled in the poll, okay? And then the executor will come back here. And so it's going to be start from here. So we're going to execute the tasks that are in the poll. And from here, we're going to start like starting executing as normal, executing imperatively like the task. So we have set time out. This set time out, we're going to schedule a task in the callback, which we're gonna log T1. But like we said, every call of system out will schedule a task in timer, like so. It's going to happen like this. And then we go to the next step. The system out also is going to schedule a task in timer, and go to like system out third system out. The same thing is going to schedule in timer, and go to promise. Promise, like said, every result, if we resolve a promise or like reject promise, is going to be scheduled in micro task, which has more priority. The second thing is we have queue micro task. The same thing is going to schedule it in micro task. And then we have only log C, which is just execution, calling a function is going to log C, right? Well, what's next? We said that micro task has a higher priority, and it should be checked by the event loop after a current task has finished. So we have finished our execution of the current task. So we're going to go to micro task. In micro task, we have to execute all this task. We cannot move to any part till we finish all this task. So if you can see, if you remember, the first task is like promise resolve. That the task that we have scheduled in the promise that we have resolved. So we're going to execute that function, log P1. So we're gonna have like P1. We have finished this. We're going to go now to the second task, which is like queue micro task. And it's contain a log M1, which means we're gonna log M1. All right, we have finished this. Now, after we finish this, we're going to go to timer, okay? But timer, we're not going to execute all these tasks because like Paul, they are macro tasks, not micro tasks that we should only execute only one task, right? But how we like one task? We will see that how we're going to execute only one task. So setting out the first task is scheduled using the first setting out call, which is T1. So if you execute this task, we're gonna have T1 output, right? After we finish this task, we have to go to micro task. Check, is there any task in micro task? No, right? Go to poll, nothing, go to timer, right? So there's nothing in poll, go to timer. Where we are in this. It's a promise. It's setting out that contain two instructions, promise and console log. So if you call promise, it's going logically to micro task because it has more priority. And the second one is going to log T2 because it's just sample call. Since we have finished this, where are we going to go? To micro task. So we have micro task, execute that micro task, which is P2, and then go to poll, nothing, go to timer. So we have a task. Then we have like system out that we are scheduled earlier. So we have just called back that we're gonna log T3, and yeah. So we have T3. Then the event loop will check micro task, nothing, and nothing, then a golden star. If there is anything, we'll wait till the task. So if you resume this is the program of the event loop. So it's just like, hey, we have event loop that will check while infinitely. We're gonna check if there is task in the event loop. Yes, get the next queue, which for example, poll or timer, and pull only one task, execute that, then go check if there is any task in the micro queue, execute all of them and do that again, right? So let's see now the event loop and browser rendering. This is very important point that guys you should understand. So, but browser rendering, what we mean by browser rendering? We should talk about the rendering pipeline. Rendering pipeline is just a process that browser run to generate a new frame to paint a DOM element in the screen, okay? Because in browser you have JavaScript, you have file, CSS. So the browser will go use those files, try to make something in the screen, okay? So like this pipeline is just like combination of process, like just for example combining JavaScript, styling, calculation, calculate the layout spacing, and paint. And compose is just like, because when they paint, we paint everything in a different layer. So this is for designer, and then they compose this. Okay, so every execution of render pipeline will generate only new page, okay, new frame that should be displayed in the screen, right? But the browser will run the execution of rendering pipeline every 60 milliseconds, okay? Because the browser should generate 60 frames per second to match the refresh rate in the screens. So that means we have only 60 milliseconds to execute our task plus painting, right? So if we have the rendering pipeline take 5 milliseconds, so we have only 10 milliseconds to execute our task. We did understand what's the rendering pipeline, but how the relationship between event loop and browser rendering. So in a way that how does the event loop affect browser rendering? So the first thing, the rendering pipeline, the browser render the pipeline after 3 steps. The first thing, we should finish the current task in the event loop. If the event loop stack is busy executing one task, no render will not execute the render pipeline. So the browser will not execute the render pipeline unless we finish the current tasks that are in execution in the event loop. The second thing is that should all micro tasks should be executed. The third thing is that we should ask if the browser should ask it's time to paint, because we cannot this counter or timer that the browser have to match the refresh rates in those screens. So the render pipeline should run after between 60 milliseconds. Every 60 milliseconds it should run. Okay, let's see that in simulation. So how does the event loop affect the render pipeline? So let's say, for example, we have this event loop, and we have here micro task, we have here a poll queue, and we have here a timer, okay? And we have render pipeline and browser. So let's say that we have a task in here in the poll queue, and that if executing this task will lead to have different tasks in different queue. Now we have to go to micro task, execute all of them, okay, right? And what's gonna happen now? Because we have finished the current task in the poll, we executed all micro tasks in the event loop. Now we have to ask the render pipeline, is it time to paint? Let's say that all what we have done earlier took only 30 milliseconds or 5 milliseconds. So the render pipeline has time. It's not going to run now because the time is not yet to render the pipeline. Okay. So the rendering pipeline is saying no. So we go back to timers queue, execute that task. So and then ask. We have nothing in the micro task queue. So go to a render pipeline. Is paint time? Yes. So the render pipeline run and generate new frame. The browser show that frame, right? And after 60 milliseconds, we have no task in event loop. Go ask the rendering pipeline. So if we ask them, because we don't have no task in event loop, so we can run because we have passed this 60 milliseconds, execute this, generate new frame, and display that frame. Okay, right? So let's say now we have a huge task, a complex task that will take us a lot of time, and that means our single thread JavaScript or event loop will be busy executing this. And let's say that 60 milliseconds has passed to rendering pipeline. Rendering pipeline cannot start executing or generating new frame because the event loop is stuck in one task. And let's say we have also we passed 60 milliseconds. Okay, that means we don't have any change in our layout. And this also we have another 60 milliseconds and no change in our UI, in our page. So this leads to browser freezing. So that's how our browser freeze freeze. Like we cannot have interaction because we cannot start the rendering pipeline and generating a new frame so that we can see a change, because the event loop is basically executing heavy task. Okay, right? So how can we help in this? To help in this, let's say we have just like this sample function, and this function will execute a heavy task, okay, complex task, and then we have to update progress bar. We will not see any, if this like took like take 2 minutes of execution, we cannot see a change in the screen, because we, like we said, we are blocking the signal thread, JavaScript thread, and we cannot execute the rendering pipeline. So to help in this, like to help avoid that, so we have to avoid blocking the event loop, right? How? For example, just like we can split our complex task into smaller tasks and schedule that task in like set time out, so that after each iteration of the event loop, after each iteration, the rendering pipeline can start and generate new frame, so we can see an update while we are executing small task in the browser, you know. So that task should be less than 60 milliseconds, or can I say less than 10 milliseconds, and everything is going to be okay. So we have done the browser part, which is very fun. So to resume everything, we can resume this by this script. So we have event loop. We have gone out like infinitely ask if there is any task in the event loop. If yes, we're going to get a queue, for example, starting from poll or timer, and we get one task, execute that. Then what? We're going to execute all micro tasks, and then we have to ask, is spend time? If yes, so we have to generate a new frame, right? Good. Now it's time to event loop in NodeJS. You have learned a lot of things today, yeah? So event loop in NodeJS. The event loop is different than browser, just like for complexity of, and things like that. But what is NodeJS? For people who don't know what's NodeJS, you know, guys, we can execute JavaScript in browser. Now we can execute JavaScript in browser to create services, to create APIs. Using NodeJS. NodeJS is platform runtime to execute our JavaScript, right? So Node.js is a multi-threaded application or runtime, okay? But JavaScript still run in single thread. It doesn't like, it's not different. It's still run in single thread. But Node.js is multi-threaded, and it's supported with different external libraries that handle multi-threading. So we need to hear a lot about saying Node.js is not blocking I/O, and right, because Node.js is supported by external library like libuv, which handle like I/O operation. So in libuv is external library that has a thread pool, and we'll try to like do some I/O operations. Okay. But in Node.js, we have to achieve concurrency, because why? We had the problem before, like one HTTP request can take a while to get executed, right? So let's start to see how event loop can help in this. So already we have said that like Node.js is supported with external libraries to handle multi-threading, okay? But JavaScript runs in single thread. So the event loop differ from the browser, event loop in the browser, in the number of queues. And this is complex because the event loop in browser is optimized, okay? So this is the queue and phase it in the event loop. We have poll, we have check, we have closer, timers, pending. They are macro tasks, and we have 2 micro tasks, right? So the poll is the main queue in which the event loop start pulling a task. We can, like we said, we have the entry file. It should be a task scheduled in poll, and we have IO event handler. Okay, if you like read file, and the handler will execute it in this poll. It will be scheduled in this poll. Check. It's a second queue that the event loop will check. This all the task in check queue is scheduled using set immediate, right? Close is special queue that handle event emitter. We don't care about this. Timers, it's same thing in like in browser. And pending is special system event. We don't care about this. Micro task 1, a special queue in which the event loop check after the current task complete, like the first one. But this micro task 1, their task is those get produced by calling process next tick, because the next tick will produce a task that has a higher priority. Okay, the micro task 2 is the second special queue in which the event loop check after the micro task 1. Okay, and those tasks are scheduled by calling resolving promise or rejecting promise. So let's see how like the behavior of event loop behave. Like they differ from they are different. So let's see, we have a task here, and it's not just task. And this task we're going like to read a file and execute some of like random system out promise resolving things like that. Okay. So at the left we have our queues, we have our script, right? We have micro task 1, 2, and we have macro task at the right, poll, check, timers. We don't care about other queues. And we're going to start executing. The first thing, like I said, everything is a function. So the entry file is also a task that's going to be scheduled like in the poll check, right? So we have the first function that we're going to execute, the first task. So let's start executing. Here, we're only going to read the file. Read the file, and when the file is loaded, we're going to execute that handler, like callback. All right? And then we're going to go like login A. That's what's going to happen. After that, nothing in the queue. We're going to like wait, reading file. Maybe it's huge, but we will, because it's synchronous, okay? It's synchronous. And let's say that the file is loaded, or maybe it's rejected, but let's say it's loaded, right? So this like the FS module will schedule the task in the event loop. That handler, that task will be scheduled in a poll, right? And the event loop will pick that task and start executing it. So like we said earlier, the system out will schedule a task in timers queue. And the second one is going the same thing. Set time out is got the second task in the queue. And set immediate log, we're going to log F1 because it's something synchron. So we're going to log that. And set immediate, we're going to schedule a task in the check. That means check before timer. And we have a promise after, which will result in scheduling a task in a promise. And then the process next tick will schedule a task in micro task 1. And then we have promise, we'll also schedule a task in micro task, right? And yes, we finished the things. What we're going to now, where we're going now. The things that are different from browser is that we can execute all the tasks that exist in the poll. We have to finish all of them, but wait, we have to finish all micro task queues. So after finishing only one task, we have to check micro task 1 and 2. And we should start from micro task 1. So in here, we're going to go to micro task 1, which is scheduled using next tick, like we said. And this is all the tasks that we're going to log N1. Okay, so we have the output at the bottom. And then we have finished this. We're going to go to micro task 2, which are tasks that are scheduled using promises. So we have here a promise. We're going to log P1 and then go to the next task is going to log P2, right? And then it's going to like also calling like process next tick, which will result in scheduling micro task in here in the micro task 1. And then set immediate, which will result in scheduling a task in check, right? Right. So here we have a task in microtask. So after we finish it microtask 2, we have task in microtask 1. So we have to come back to microtask 1 and execute N2 like so. And now we have nothing in microtask 2. We're gonna come back to poll. There's no task. Go to check. We have two tasks in check. So we're gonna start executing. The first one is E1 log. So we executed that. You see the output at the bottom. And then we have to check microtask. There's nothing. Microtask 2, nothing. Come back to check. We have to execute all tasks in the queue. That's how it differs from the browser. So execute this will lead to result in E2 in outputs. And now come back, microtask nothing, microtask 2 nothing, and timer. Now we're going to go to timer. We have a timer. We have system out T1. We have logged that. Microtask 1, microtask 2 nothing. Go to timer. We have a task. We should log T2, and then we're gonna read a file. Right. So we're gonna read file. Nothing in the event loop. But after that file will load, we're gonna have a task. The executor will be in the poll, and we're gonna log F2. We have system out. We're gonna schedule a task in system out, and we're gonna now go to microtask, check nothing, microtask 2 nothing, go to check nothing, go to timers, and we have T3. So here's the result. Here's the result, and we have we can resume what we said, everything, and how the event loop behave in this script, in this program. The event loop gonna start executing, checking if there is task in the event loop, get a queue, the first queue, the second queue, and start checking if there is any task in the current queue. Pull that task, execute. When we finish that, check the microtask 1. The second, after finishing that, execute all tasks in microtask 2, right? Good. How about React Native? We're gonna go quickly about using this. So React Native is just it's a framework for mobile, so we can write JavaScript, develop a mobile application using JavaScript. So in React Native, going that briefly, we have two threads. We have JavaScript and we have native thread. And we have bridge, okay? So, for example, JavaScript render a button that will send a message to native bridge to create a button in the screen using that bridge, okay? So, for example, let's say that we have a button in our native screen. So, and we have handler, okay? We have registered and handler. If user click on that button, so the event loop will notice that. We'll set the post to the JavaScript bridge, and that message should be scheduled. That task should be scheduled in the event loop. But if we have the event loop is stuck busy executing a heavy task, which means will not be able to handle any message that come in from native bridge, which also result in screen freezing in mobile application. So to resume that, how it does work. So we have JavaScript thread, native thread. There are messaging between them using bridge. So if only we have our JavaScript thread is busy executing or stuck in one task, it will not handle any event from the native bridge, which will lead also to screen freezing. So to resume the conclusion, I would say we have to write a code that work for our event loop and not against that, so to prevent the performance bottleneck in our application. So it's very important to understand the event loop, so we can read the program, you can do many things like that. So thank you.
Okay, so now we can begin our Q&A session. So please, guys, write your questions in the chat if you have any. We're gonna wait a couple seconds to see. Okay, someone is typing. Wojtek wants to know, do you like React Native, Azadin? He's
Well,
really curious. He wants to find out.
React Native, behind the React Native is Facebook team. It's mean like using React Native, you can build different application, cool application, but it depends on the context. If you need like real performance application, I don't suggest that we should use React Native. Because like I said, React Native, we have only one thread in JavaScript, and we have thread in native. If we have a complex task in like JavaScript, so it's going like we lead to bottleneck in our performance of application. But it does its works, it does React Native, it does its works.
Okay, we have another person writing. So, okay, that was it. Let's wait another couple seconds.
Yeah, right. Well, React is good. React Native is good. It does like the company created cool application using it. So, but we are waiting for good performance and good features from like the team. So it's promising.
Okay, we're gonna wait another minute just to make sure that all the questions were
Any
answered.
question about like event loop in browser, like render pipeline? If you have any question, ask. Right? No, like it's like it have like micro event loop is separated than EBUV. EBUV is just like an external library that handle IOs. Okay, so which means if we have like we want to read a file, we can read file like synchronously, which will block our JavaScript thread, or we can ask libuv to do that for us. But we're not going to ask libuv directly. It's internally thing. We're going to just like ask FS, hey, read this file, and when the file has finished completed, so schedule task in the event loop, and then the JavaScript will execute that task handler. So that two micro tasks are in the event loop. Event loop has many different views, so it depends. DBV is different than.
How often do you need to use your event loop knowledge in your day-to-day work, Azadin?
Well, like if you create like sample application or like sample button depending on the context, you don't need that knowledge. But when it comes to figuring out what's causing browser phrasing problem or how to handle things, you have to, because it's a critical component. It's critical components to learn about, to understand how things work. Like I said, like scheduling tasks using setting out and then promise and things like that. More like at least you have to learn that you have not to have complex tasks which is synchronous that block your single thread. So you have to understand the event loop. And the more you understand, the more you will like write a better code for your application.
Does your work mainly consist of front-end or back-end tasks?
So, like at the beginning, like we have talked two different problems. Like for example, browser, we can have browser phrasing, or like in backend, we can have like one active request take a while to get executed, which means that handler, our JavaScript handler, it's a heavy task. For example, reading file from the system, which with in synchronous way. This could lead like to like we cannot handle other requests. We can only handle we cannot handle other requests. So the event loop is like it's in every platform that JavaScript can run. That's the idea. So yeah.
Okay, so let's see. There's another person typing, so let's see if there are more questions. What about service workers?
Well, you see, not just like no, it's not just it's like a browser. Browser, like we said, like it's a method-threaded. Okay, a browser is like not just it's method-threaded application, but JavaScript run in single thread. And workers are here to help us to not block our UI thread because browser we have UI thread where we manipulate the DOM element, execute things like that. So what worker is another thread, but let us do not block our main thread. Okay, and service worker also has also their instance because there's separated instance of JavaScript. They have their own event loop and things like that. You know, for example, how can we communicate between main thread in browser and web workers, service worker? It's just like by messaging, post message, right? That message is going to be scheduled also in special queue in service worker. So service worker has also their own event loop, but like they are tiny, you know, because it's not, you don't have rendering pipeline. It's not complicated. It's easy.
Okay, I cannot see new questions, so I guess we can move to another slide. If you guys have any questions, you can contact us under the email displayed on the slide. And that's it for today. We hope you guys enjoyed the meetup. See you next month, and make sure to follow us on LinkedIn and Facebook to stay up to date with the details. So thank you and have a nice evening.
Thank you, guys. Thank you so much for your presentation, my presentation, and thank you, guys. So yeah.
Okay, so goodbye, everyone.
Bye.